that is equal to V. So we'll use the conservation of momentum equation, COLM, applying conservation of linear momentum. So what we'll do, initially block velocity was 2, so m1 u1 plus m2 u2 equals m1 plus m2 into v, because they stick together, no? That they have mentioned in the problem, right? See, loss in kinetic energy will be maximum only and only if they will stick together or the collision will be inelastic, right? Means they will stick together and they will start moving simultaneously. Only in that case, the loss in kinetic energy will be maximum, right? This is the condition for loss in kinetic energy. So you might have applied this way, right? Here U2 is given 0. So we know that this U2 is given 0 because second was block was rest initially. So this quantity will become 0. So M1 is 2, U1 is 2. So 2 into 2, that will be equal to M1 plus M2. Both have the equal mass, 2 and 2. So 2 plus 2. Common velocity is V. So both of the block will be moving with common velocity V equals 1 meter per second, right? So loss in the kinetic energy will be how much? Delta Ke half M V2 square M1 V2 square plus half M V2 square means V square, half M1 V square plus half M2 V square minus half M1 U1 square plus half M2 U2 square. This is the loss, right? So we can take half M1 M2 common. So 1 by 2 into 2 is 1. So simply it will be 2V square minus U2 is 0. So half 2 to cancel. U1 was 2. So minus 4. So V is 1. So 2 minus 4 equals minus 2 joule. So loss is negative. That means what? Final is less than the initial, right? Hence kinetic energy is decreasing. So we can write that. Hence delta Ke equals minus 2 joules. All right. Now they have given that if the actual loss in kinetic energy is half of this maximum, find the coefficient of restitution. So actual loss we have to take half of this means 1 joule, right? Okay. This was part A. Now we will consider part B. According to the problem, the actual loss is half of the maximum. That is, loss equals max by 2, that is equal to 2 by 2, that is equal to 1 joule. Okay. Any problem till here? Okay, so what we have to decide? Coefficient of restitution. So in this case, again, we have to find out the final velocities of the blocks, right? V1 and V2. So for maximum loss, we have assumed that the both of the block will be having common velocity. Are you getting the point, Ojas, in this problem? What we are considering, if we need maximum loss in kinetic energy, both of the block will be having common velocity that we have assumed in part A. But this time the loss is not maximum because the loss is half of the maximum, right? So this time we can't take both of the velocities as common. So this time they will be having velocities v1 and v2, right? So delta ke we have to define again for the part B is equal to half m1 v square v1 square plus half m2 v2 square minus half m1 u 1 square plus half m2 u2 square. You understood? V1, V2 is unknown for this part B. So M1 is 2, M2 is 2. 2 and 2 cancel. So remaining will be V1 square plus V2 square minus U1 square plus U2 square. But U2 was 0. Hence it can be written as V1 square plus V2 square minus U1 square, and this is given 1 joule, right? Now U1 was given 2. U1 was given how much? 2. So V1 square plus V2 square. Wait a second. Now let you tell me one thing. This point I was just trying to discuss. Can we write V1 square plus V2 square is equal to V1 plus V2 whole square plus V1 minus V2 whole square divided by 2. This is just a mathematical identity. Can we write it like this or this? Okay. So what I'm trying to do is, you know the formulae, according to the formulae, just a sec. We know that V1 minus V2 is defined as E into V, where E is coefficient of restitution. I mean, how we are getting it? Just a sec. I don't want to write it directly, but this can be written as E into U2 minus U1, correct? Uh, for a second, if we forget this part, I mean this part, can we write directly this is equal to this according to the definition of coefficient of restitution? Let us forget this for a moment. So is it okay if I write it like this? Or just V1 minus V2 can be written as E into U2 minus U1. But for this problem, U2 is 0, right? For this problem, the velocity of the second block, the initial velocity of the second block was 0 because that was at rest, correct? And U1 was given how much? Can you tell me? U1 was given how much in this problem? 2 meter per second, and U2 was 0. So we will write this was 0 and this was 2 meter per second. So what we'll do? V1 minus V2 could be written as minus 2 times E here, right? Squaring both sides. V1 minus V2 whole square could be written as 4E square. Any problem? Now we will substitute this value here. So V1 square plus V2 square. Hence, V1 square plus V2 square could be written as, let us consider this equation as 1. So we are just going to substitute the value of V1 minus V2 square in equation number 1. So it could be written as V1 plus V2 whole square plus 4E square, correct? Divided by 2. Any problem till here, Rogers? Okay. तो अभी हम क्या कर सकते हैं, वी नीड वन मोर इक्वेशन यहाँ पे, जस्ट अ सेक. I hope we have already applied the conservation of energy equation. So from previous page, we were already applied the conservation of energy, and using the conservation of energy, you can see m1 u1 plus m2 u2 is equal to, it was how much, m1 plus m2 into v, right? But this equation will not be applicable because last time in part A the velocity was common, but this time the velocity is not common. So what we'll do, also applying the conservation of energy, when you will apply the conservation of energy, what will happen? Let me write down, m1 u1 plus m2 u2 must be equal to m1 v1 plus m2 v2. Why we are writing m1 v1 plus m2 v2? Can you tell me, Ojas? Why not we are taking common velocity? Yeah, this is not perfectly inelastic collision because loss of kinetic energy is not maximum this time, right? Because of that, we can't take v1 and v2 as common and unique. So due to that reason, what we'll do, m1 and m2 value, u2 is 0, again u2 is 0, as per the previous condition, u2 is 0. So we are taking this quantity as 0 because u2 was 0. So m1 was 2 and u1 was 2 also. So 2 into 2, 4. 2 into v1 plus 2 into v2. So what we are getting? v1 plus v2. This time we are getting 2. Let us consider this is equation number 2. So what we'll do? We will substitute the value from 1 and 2. So here you can see v1 plus v2 we have got 2, right? So v1 square plus v2 square can be written as 4 plus 4e square divided by 2. That comes how much? 2 plus 2e square. Any problem? v1 minus v2 we have substituted, and yeah, so it become 2 into 2 plus e square. So we can take common 2 into 1 plus e square. So v1 square plus v2 square, directly now we can substitute 2 plus 2e square minus u1 square is equal to 1. u1 we know that that was 2 actually. So 2 plus 2e square minus 4 equals 1. So 4 plus 1, 5. 5 minus 2 is 3. So 2e square equals 3. Hence, we are getting e equals root 3 upon root 2. Is it the answer? Where we are doing the mistake then? Just a second. I'm doing some mistake here. Let me check. Just a second. Okay, this time they have given loss. So they are taking initial minus final. They are taking what? Initial minus final, right? So what we have to do is, while writing the final equation, we will take this as plus and we will take this as minus. Okay. And we can put a modular sign here just to avoid any confusion. Okay. So what we'll do? This will become plus and this will become minus because loss is the negative, hence the energy is decreasing now. Plus and it will be minus. So what we'll do? 6 2e square equals 2 plus 2e square equals 3. So 1 plus e square equals 3 by 2. Hence e equals 1 by root 2. I hope you understood. You understood, Ojas? So you might have mistaken at that point. You might have taken as the same way like final minus initial. Here we have to take initial minus final because kinetic energy is decreasing this time, right? Any problem? So we have got the value of v1 square plus v2 square and substituted the value of v1 minus v2 and v1 plus v2 using conservation of momentum equation, right? So we can just mention here delta ke is equal to ke initial minus ke final because kinetic energy is decreasing this in this problem. Just to avoid the any kind of error. Otherwise, we were getting root 3 by root 2. Okay. That is entirely a different answer. You did the solution in same way, or just the way I did, or you did in a different way? Right. So will you try the problem number 35 now? आप ये नोट डाउन कर लीजिए इसको पूरा कंप्लीट Have you noted down the previous slides? And then you must try 35. Are you trying 35th problem?